Alright, in this video we're going to be going over our noble gas configuration and Lewis dot structures. So this is going to be page 12 of our notes. Now, with our noble gas configuration, we're able to use the noble gases as points or as landmarks in order to shorten our electron configurations. So, how this will look is going to be that our noble gases are always going to be here. We're able to assume that we know where these are. Kind of in a real world example, kind of like around here at Saxe, is that we all kind of know where the 7-Eleven is. So because we know there, we can then give directions. So it's able to shorten our directions just a little bit. So the very first thing, let's go ahead and write out the noble gas configuration for our magnesium. With our magnesium right here, what we're going to do is that we're going to go on the row above and we're going to find its noble gas. So in this case, the noble gas on the row above is our neon. So how we're going to write this is our Ne in brackets. And then we're going to finish off the electron configuration. So our Ne is in row 2, so we're going to continue on to row 3. So we are going to be in our 3s, and it takes our 2 electrons to get to our magnesium. So we get our 3s2. And that is going to be the noble gas configuration for magnesium. So it shortens our electron configuration a lot. All right, let's go ahead. Let's take a look at another example. All right, let's go ahead. Let's take a look at sulfur. All right, so our sulfur is right here. So as always, we're going to look at our noble gas that is on the row above. So looking at the row above, it is going to be neon. So we have our neon that is in brackets, and we are going to continue on with our configuration. So we are now in row 3. We are entering into that S block, and it takes our 2 electrons. Continuing on all the way over, we are still in row 3. We are entering into the P block, and it takes 4 electrons to get to our sulfur. And now what we have is the noble gas configuration for our sulfur. It's going to be our Ne, 3s2, 3p4. All right, let's go ahead. Let's take a look at the noble gas configuration for iron, so our Fe. So our Fe is right here. We are going to take a look at the noble gas that is on the row above. In this case, it is our Ar, our argon. We'll put our symbol into brackets, and then we're able to continue. So next row is row 4. We enter into that S block, able to hold 2 electrons. Now remember, we're about to enter into the D block, so we're going to lower our row number by 1. So instead of being 4, it will be our 3D. And then we get our 1, 2, 3, 4, 5, 6. So we get our 3D6. And that is going to be the noble gas configuration for Fe. All right, let's go ahead and take a look at the noble gas configuration for Au. So for our gold. So our Au is right down here. We're going to find the noble gas on the row above. In this case, it is our xenon. So our Xe in brackets. Move on down. We are going to be in row 6. All right, so we are in row 6. We are entering into our S block. It is able to hold our 2 electrons. All right, now this is our first example on the video that we have, in which case we need to go into our F block. So remember, our F block is this green block down here at the very bottom. And our F block is also kind of special. It's very similar to our D block. But instead of lowering our row number by 1, whenever we enter into the F block, we are going to lower our row number by 2. So we are originally in row 6, but whenever we enter into the F block for the first time, this is going to be our 4. So we are going to get our 4F. And then our F block is able to hold 14 electrons. So we're going to get 4F14. Now, whenever we're going to exit our D block, so whenever we get out of whenever we exit our F block, we are going to be entering into our D block. And so remember that our D block, we are going to lower our row number by 1. So instead of it being 6, we're going to go to 5. So this will be our 5D. Right, so we have our 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get our 5D9. And so this is going to be our noble gas configuration for AU. Again, the biggest thing is whenever we enter into that F block, we are going to lower our row number by 2. Whenever we enter into our D block, we're going to lower our row number by 1. All right, and then I'm going to leave this example for in class so that we are able to take a closer look at it, along with our xenon. All right, so next what we're going to talk about is going to be valence electrons. So our valence electrons are going to be the outermost electrons, also known as our highest energy level. So if we think about our Bohr model, we have our nucleus that is in the center, and then we have those orbitals on the outside. So our valence electrons are going to be those electrons that are on the outermost shell. These are going to be the electrons that are going to be interacting with other atoms. So the valence electrons are going to be the ones that cause chemical reactions to happen. So valence electrons are super important. Now, we do have our valence electron configuration, and this is going to be the electron configuration that only uses the valence electrons. So it's only going to include the s and p orbitals. And we're just going to focus on our highest energy level. And we'll take a look at some examples of that more in class. Now, what I really wanted to get to was going to be our Lewis dot structures. So our Lewis dot structures only show the valence electrons, and the valence electrons are represented as dots placed around our element symbol. Now, what I've also placed in here is going to be a periodic table with our valence electrons. So what we have in column 1, all of those elements, they will always have one valence electron. So no matter what, so this is going to be like our lithium, this will be our sodium. All of those always have one valence electron. Right, column 2. So column 2 right here always has 2 valence electrons. Now, our transition metals, these elements in the middle, the reason that they are called transition metals is because their valence electrons are going to change depending on like the specific atom. So these different elements can have up to 5 different types of valence electrons. So we typically just kind of ignore it. All right, then going into essentially our column 3 or 13, we are going to have 3 valence electrons. And this is going to continue all the way to our noble gases. So our noble gases are going to have that full outer shell, The only exception to this is going to be our helium. All right, our helium only has 2 valence electrons, and that is going to be considered to be full. So helium will only have a full outer shell of 2 valence electrons, and that is just because it is so small. It is a really small atom, so it only needs to have 2 valence electrons to be full. All right, so let's go ahead and take a look. So we're going to draw the Lewis structure for Na. All right, so first thing that we're going to start off with is going to be just our symbol. So we get our Na right here. Taking a look on the periodic table, our sodium is in column A, or column 1. So this means that it only has 1 valence electron. So what we're going to do is just have 1 dot. And that is going to be our Lewis dot structure. So it will be our symbol with the number of valence electrons represented as dots placed around the symbol. So that will be our sodium. All right, next, let's look at our magnesium. So magnesium is our Mg. Our magnesium is in column 2. So because it is in column 2, it has 2 valence electrons to it. So we're going to have 1 valence electron on each side. So it will look like this. So 2 valence electrons, 2 dots. Now, whenever we have more than 1 dot, how we are going to place it is going to be in a clockwise fashion. So we are going to place our dots around our symbol clockwise, and we are not going to pair them up until we have to. All right, so let's go ahead. We'll take a look at our Lewis structure for boron. So our B. All right, it is in column 13, or column 3, sometimes as we call it. So this is column 13, so 3 valence electrons, so we get our 3 dots. Again, we are going to go in that clockwise fashion around our symbol. And that is going to be our Lewis dot structure for boron. All right, let's go ahead. We'll take a look at carbon. So we have our C. Carbon is in our column 14. So we're going to have 4 valence electrons. So that means our 4 dots. We'll place our dots clockwise around our symbol. We have 4 of them. We are done. All right, taking a look at nitrogen. All right, nitrogen, it is in column 15. So that means that we're going to have 5 valence electrons. So we get our 1, 2, 3, 4, and our 5th one is going to be paired with our original. And so what we're going to have is going to be this right here. All right, so looking at our Lewis dot structure for oxygen. Oxygen is in group 16, so we are going to have 6 valence electrons. So we get our 1, 2, 3, 4, 5, 6. So we're going to have our 6 valence electrons around our symbol. Next, we have our fluorine, our F. All right, so our fluorine is in group 17. So this means that we're going to have 7 valence electrons. So we're going to have our 7 dots placed around our symbol. And it will look like that. All right, and looking at our last one, this is going to be our neon. So this will be our Ne. Our neon is our noble gas. It is going to have our 8 valence electrons. So group 18, 8 valence electrons. We get our 1, 2, 3, 4, 5, 6, 7, 8. All right, so 8 is our maximum number that we can have. So this is going to be our full outer shell. This is going to be our maximum number of valence electrons we're able to have. All right, now that covers our Lewis dot structures and our noble gas configurations.